Hello, this is Britt Kessel with another example video. In today's video, I'm covering example 2 from section 6-2 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to understand compound interest. So the first thing I want to do is I want to explain what compounding is. All right, I'm going to go ahead and move my little dude who's making it rain a little bit. There we go. So say I get a credit card. Okay, I'm going to put $1,000 on that credit card. I'm going to say that it has a 10% interest every month. That's a terrible rate. Don't go for a credit card that has a 10% interest every month. All right? Just don't do that. Okay? So, at the end of the month, if I have not paid back that $1,000, the bank will go ahead and they will charge me interest, right? So, now the balance on my credit card is now the $1,000 plus 10% interest, so plus $100. So now my credit card is $1,100. So now I'm going to say that I'm terrible and I don't pay my credit card again. So the bank is going to charge me interest, but they're not going to charge me interest on my original 1,000. No siree. What they do is they charge you interest on the balance on your credit card. So this credit card, even though I may not have used it, now has a balance of $1,100 because it has the original 1,000 and the extra $100 that's on there. So when they go to charge me the interest, it's on $1,100, and so my interest that I earn on this card is now $110. So my credit card now has $1,210 on it. So I'm going to say that I'm going to pretend I'm not getting any late fees here, but they tack those on. They sure do. But let's go another month on this. All right, the bank is going to charge me interest again. And you betcha, it's not on the 1,000, it's on my balance. So this time, the interest that they're charging me is $121, which brings my balance to $1,331. So check it out. Do you see how every month my interest, the amount that I'm paying, is higher? That's because compounding, or calculating the interest, also calculates interest on top of the interest. So not only are you paying interest, but you're paying interest on top of your interest. And that is where we run into issues. Okay? So as young people, I trust you're young people watching this video, don't get credit cards right away, y'all. Not until you guys have learned how credit works. Because what seems like an innocent, say this is even $10, say it's an innocent $10 burger, in 3 months, if you haven't paid that $10 back, now it's a $13 burger. See what I'm saying? Okay. So now that you guys understand what compounding is, I want us to talk about what that compounding does. All right, so we have this situation with Tamira, who's going to be investing a certain amount of money with an annual interest rate for 3 years. And she's going to be comparing 4 different compounding times. All right, and I want you guys to see the effect that compounding has. Okay, remember, compounding just means to calculate the interest or the interest on the interest. All right, so in most of these equations, everything's going to be the same. Okay, so the principal amount is 5,000 on all 4 of these. All right. The 4% annual interest, remember you have to convert it to a decimal, but that's going to be the same on all of these. And the amount of time is still 3 years, and that will be the same on all of these. Okay, so we're holding all of those constant, but we are changing the number of times that we're compounding it yearly, okay? So when I say annually, I'm compounding it once per year. When I say semi-annually, semi means 2 times per, essentially. So if I'm doing it semi-annually, I'm doing it twice per year. That means it's compounded like every 6 months, okay? Now, quarterly, you guys are probably very familiar with the word quarterly. That means 4 times a year or every 3 months. And then monthly, that happens 12 times a year because there's 12 months in a year. Okay, so I want us to calculate these equations and see exactly how much this impacts things. All right, so here in this first one, I'm just plugging in the variables as I see them. Oops, starts with an A, not a P, doesn't it? There we go. So my amount is equal to $5,000 times 1 plus 0.04 over 1, and then 1 times 3. And we tend to clean this up a bit, okay, y'all? So, like, I'm going to start maybe by cleaning up the inside of the parentheses because it's going to save me work on typing it later. Although, I think I'm going to do this in Desmos because calculating this 4 times is annoying, y'all. So let me show you how to do it in Desmos. So with Desmos, what we are going to do is start by just typing out the formula. So there's our formula, okay? And so what I can do here is I can add sliders for each of the 4 variables, okay? Now remember, our time we set at 3 years, all right? Our rate was 0.04, and our principal, our starting amount was 5,000. And so what this is going to do is this is going to allow me to play with that monthly amount, essentially, the number of times we compound. So I could change that m as many times as I want, and that's kind of cool. So here we go. Now, one thing I need to do is I need to change my y-axis so that I can look at it a little better, right? My initial amount that I'm putting in is $5,000. So I'm going to start my y-axis at maybe $4,500. And then I'm going to make it go, I don't know how big this is going to get, so I'm going to say maybe 8,000, and if we fall off the graph, we'll fix it. Yeah, so there we go. So let's check out that monthly compounding, okay? I'm going to erase this extra writing on here. Well, I'll fill it in with what would go into the calculator. So this is what would go in. All right. Now, when you guys do these, you guys need to make sure that you guys kind of clean it up before you go into Desmos. That's what I would recommend. Just because this is the biggest error in this type of problem that I've run into with students is they don't know how to properly use their calculators. And then what ends up happening is they get an answer and they might not understand exponentials well enough to realize if an answer is reasonable or not. So the best advice that I can give you as a teacher is to clean up what you're going to type into the calculator before you get into there. Okay, and that's going to eliminate a lot of your errors. Now you'll notice on this fourth one, I don't really clean it very good because when I do 0.04 divided by 12, it gets me a repeating decimal that goes on for forever. So this one, I just clean up the exponent and try to remember to work my way from the outside in, okay? Okay, so let's check out our values. So when m is 1, here's our equation. We get $5,624.32. 24.32. Oh, I'm so bad at remembering numbers, y'all. Okay, so there it is if we compound it once per year. Alright, so now we're going to take that up a notch. Now let's look at the one for twice a year. So I'm going to change this m value, the compounding number, to 2. Okay, and it moved up a little bit. 56, 30, 81. And remember, I rounded that, right? I rounded that to the nearest penny because we're talking about money, y'all. So our next one is the quarterly one. So I'm going to change that M value now to 4. And look at that, 56, 34, 13. 56, 34, 13. And one more time. This time we're going to get a little wild. We're looking at monthly now. Apparently I didn't need to go so wild on my y-axis. 56, 36, 36. All right. So let's check out these 4 values. So, right, here's where I'm getting more number of times compounding. And do you see how each time the value in the account gets bigger and bigger and bigger? So the more often that we compound, the higher the interest. And again, that's because we're calculating interest on interest on interest. So if we're doing this more times in a year, instead of doing just one jump, we're doing the multiple jumps, and that's why it grows so quickly. All right, so let's go ahead and do the try it. Okay, I'm going to go through it fairly quickly, just because this is already kind of a long video. Y'all might not remember the formula, but I do. So the 3,000 is our P. It earns 3% annual interest. Remember, that's our R value. And it says it's compounded monthly, so that M value is 12. All right, so now I'm going to go ahead and calculate this for 10 years. That's my T, or 100 years. And I'm going to do this twice. So I get that my amount is equal to my principal times 1 plus my rate divided by my monthly rate, or by my number of times compounded, raised to the number of times compounded times 10. Alright, now I'm going to clean this up. I'm just going to use my little Desmos calculator I did in a second, because it's easier. But I want to show you guys just to clean stuff up. So there for the exponent, 12 times 10, oops, is 120. Got too excited and put too many lines. And then on our next part, 0.03 divided by 12 is 0.0025. And if I add 1 to that, I get 1.0025. And so that's what I would type into my calculator on Desmos. So if I go to my Desmos and I adjust things, remember that initial principal is 3,000. All right, we're changing our M again to 12 is there. Our rate is 3%, not 4%. And then our time in this case was 10. So if I plug that into Desmos, I get 404806. There we go, so 4048.06. Now let's do that same thing with 100 years. Okay, so everything in this formula is staying the same, except in the exponent up here, it's 100 instead of 10. So if I clean up in the parentheses, it's still going to get me the 1.0025, but up here, up top, I get 1200. And you're going to see this is going to blow up so fast, right? Because exponentials grow so quickly. So if I come over here to the t and I put in a 0, look at that, that just falls right off my graph. And I'm looking and looking and looking. See, I'm at the 21,000 marker. It's not there yet. And I'm going to zoom a bit. Oh my lord. Oh, there we go. 60,031.45. Oh, thought I'd remember it. I felt good about it. Need the 45 cents on there. So we had something that was just at 3,000, and then 100 years later, it's now 60,000. All right. So that's why when you're doing like retirement stuff, right? Usually you retire, I don't know, after 20, 30 years in a field. Let's look at that, right? Let's look at what this would look like at 20 or 30 years. Let's look at 20 years. So if I invested that money at 20 years, after 20 years it would be worth 5,400. If I change that to 30 years, it would be 7,370. So after 30 years, that $3,000 has more than doubled. All right, it's, I don't know, a decent amount. Okay, so that's where we get into this idea of investing when you're young, because the money grows faster the longer that it's in an account. Okay, but there we have it, guys. That is understanding compound interest. Until next time.